Welcome back to 3 Inquisitive Kids. Here is problem 2. The tiny island nation of Afghanistan is a cone with height 12 meters and base radius 9 meters, with the base of the cone at sea level. If the sea level rises 4 meters, what is the surface area of Afghanistan that is still above water in square meters? Now pause the video, maybe draw a diagram to help you visualize this problem. And before you go, I'm going to tell you that the surface area of a cone is equal to pi times the base radius multiplied to the sum of the radius and the square root of the height squared plus r squared, and that is the formula. Now pause the video and try to solve this on your own. Okay, let's come back together. So we know that this is a cone. So let's first draw a cone. We know that it has a height of 12 meters. So if we drew a dotted line to show its other side, and this was the center of its radius, we know that this part would be 12 meters. The base radius would be 9. So here is 9. And we know that the base is at sea level. So if this was the base, we know that this was the original sea level. And now we have another motion here. We're saying that if the sea level rises 4 meters, so if the sea level became at here, what would be the surface area of Afghanistan that is still above water? So it's still going to be a cone, but the parts of the cone that is above water, what is the surface area of that? Well, we know how to find surface area of a cone. And mind you, we were talking about the surface area that is above water. So in the end, we're going to have to subtract the base area of the small cone. And we can draw a small cone like that to show the smaller island after the water goes up. And now let's substitute the values into the surface area of a cone formula. So we know it's equal to pi times the radius. We don't know the radius of this small cone. How do we find that? Well, again, here is when similarity comes in. We know that the difference between the heights of these two cones is 4. So if the total is 12, then we know this part is 4 and this part is 8. And we get 8 by multiplying 12 by 2/3. So 2/3 is the scale factor. 8 is 2/3 of 12. So again, we know that their radiuses must be scaled by the same factor as well. The original radius was 9, so if we multiply that by 2/3, we get 6. So now we have found out the smaller radius, which is 6. So we can continue substituting. So we have pi times 6 times, and we have 6 plus the square root of the height squared plus the radius squared, which is 8 squared plus 6 squared. So now all we have to do is solve. So we have 6 pi on the outside multiplied by 6 plus, and as you can see, this is basically the Pythagorean theorem. So we know that this is 10. In the end, we have 6 pi times 16, which is 96 pi. Now, hold on there. This is very close to our answer, but not yet, because we're talking about the part that is above water. So always go back and reread the problem because you might not know what you're missing. And now we're going to subtract the base circle. We know that obviously the area of a circle is the radius squared times pi. And we know that the radius is 6 in this case. So we have 36 pi. Now if we subtracted 36 pi from 96 pi, we would get 60 pi. So our final answer to the problem is 60 pi. Again, we used similarity in 3D geometry. So similarity is a very important part when it comes to grasping geometry problems. Always comparing shapes, comparing ratios, and then finding that scale factor. That's what makes you be able to solve most of these geometry problems that come up on AMC8.